Welcome to this lecture. In this lecture, we will see some of the examples regarding the successive differentiation. Let us start with this one. Suppose it is given y is equal to e raised to ax sine bx, and we are supposed to prove this term. And we are also given a and b are constants. Let's understand the question first. We are supposed to prove this term, and in this term y2 is given. Initially we know that y is differentiated twice, right? Only this much information is enough for us. Let us start with the answer. It is given y is equal to e raised to ax sine bx. Now we will differentiate this equation with respect to x. It will give us y1 is equal to the chain rule will apply, e raised to ax into d by dx of sine bx plus sine bx into d by dx of e raised to ax. This would give us y1 is equal to b e raised to ax cos bx plus a e raised to ax into sine bx. Now in this result we can see this term is nothing but y. So we can rewrite this equation as y1 is equal to b e raised to ax cos bx plus a y, or we can write y1 minus ay is equal to b e raised to ax cos bx. Say this is result number 1. We know we are supposed to differentiate y twice, then only we will get y2. So now let's differentiate result number 1 with respect to x. Again the chain rule will apply. On the left hand side y1 will become y2 minus ay will become ay1, and on the right hand side chain rule will apply. We can take b out of the bracket, and now we will apply the chain rule. E raised to ax into d by dx of cos bx plus cos bx into d by dx of e raised to ax. y2 minus ay1 is equal to b in the bracket. This would be minus b e raised to ax sine bx plus a e raised to ax cos bx. Now let's first multiply this b inside. y2 minus ay1 is equal to minus b square e raised to ax sine bx plus ab e raised to ax cos bx. Now let us see e raised to ax sin bx, this is y, and b e raised to ax cos bx, this term is y1 minus ay, right? Let us put the values. y2 minus ay1 is equal to minus b square y plus a into the bracket y1 minus ay. Now let us simplify this one. y2 minus ay1 is equal to minus b square y plus ay1 minus a square y. And again simplifying this, we will get this result: y2 minus 2a y1, which is these two terms, plus a square plus b square y is equal to 0. Proved. Let us see the next example. If x has some value, y has some value, we are asked to find d square y upon dx square. Here the term a is only constant. The term t, which is variable, and x is function of t, y is also a function of t, and we have to find d square y upon dx square. This is an excellent example, and there is a chance that students might make a teeny tiny mistake. What is that mistake? Say we are asked to find dy upon dx. Then how will we find this? We will first find dy upon dt. Then we will find dx upon dt. And now we will multiply dy upon dt with dt upon dx, and we will get dy by dx. But this method is only valid for finding the dy upon dx. Say if we do d square y upon dt square and do d square x upon dt square, and if we multiply d square y upon dt square with inverse of d square x upon dt square, it would be dt square upon d square x. This is not equal to d square y upon dx square. This is actually equal to d square y upon d square x. This is the main reason for solving this question. It is quite easy. So let us see how it is done. Let us solve this side by side. X is equal to a cos t plus t sin t. Y is equal to a sin t minus t cos t. This is given. Differentiate both with respect to t. On the left side, we will get dx upon dt, that would be equal to a into the bracket minus sin t, the chain rule will apply, plus sin t plus t cos t. On the right side, we will get dy upon dt is equal to a into cos t minus cos t plus t sin t. Now, the final answer for dx upon dt would be at cos t. The final answer for dy upon dt would be at sin t. We can find dy upon dx is equal to dy upon dt into dt upon dx, which would be equal to at sin t upon at cos t, which is 10t. Now what we are supposed to do, if we are to find d square y upon dx square, say this is result number 1. Now we will differentiate result number 1 with respect to x. We will get d square y upon dx square is equal to d by dt of 10t into dt upon dx. Of course, we know this is the chain rule, and as we know t is not constant, it is also variable. We are supposed to multiply dt upon dx, and the answer would be the differentiation of 10 is secant square into, from this dt upon dx, we know dt upon dx, which is 1 upon 80 cos t into 1 upon 80 cos t, and the final answer would be d square y upon dx square is equal to secant cube t upon 80. Let us go for the next example. Y square is equal to f of x is given, where f of x is a polynomial of third degree, and we are supposed to evaluate this term. If we understand the question correctly, half of our work is done already. So let us first find out what are we supposed to evaluate. What is this term? So let us first simplify that term. It is given d by dx of y cube into d square y upon dx square, which is equal to 3y square into dy by dx into d square y upon dx square plus y cube into d cube y upon dx cube. So we are supposed to evaluate this term. Say this as result number 1. Now let's further understand this question. F of x is a polynomial of third degree. Why it is given? Let's assume if f of x is to be x, then f dash of x would be 1 and f double dash of x would be 0. In any case, for first degree, the second derivative would be 0. If f of x is a polynomial of second degree, then this term would be 0. If f of x were to be the polynomial of first degree, then there is chance that this term is also gonna be 0. and the questioner is asking us not to consider any of this term as 0. That is why it is written f of x is a polynomial of third degree. Right? Now we can see the solution. Y square is equal to f of x is given. We can differentiate it with respect to x. We will get 2y into dy upon dx. It would be f dash of x. Say this as result number 2. Differentiating 2 with respect to x, we will get 2y into d square y upon dx square plus 2 dy by dx's whole square is equal to f double dash of x. Say this as result number 3. Here in the question we are asked to differentiate y thrice. Here we got only the differentiation d square y upon dx is square. So we are supposed to differentiate 3 again. So differentiating 3 with respect to x, again the chain rule will apply. 2 into dy upon dx into d square y upon dx square plus 2y into d cube y upon dx cube plus 4 dy by dx into d square y upon dx square. This would be equal to f triple dash of x. Here these two terms are similar. We can add them. It would be 6 into dy by dx into d square y upon dx square plus 2y into d cube y upon dx cube, and this would be equal to f triple dash of x. Now let us see the question. The question has y cube. There is no y cube in here. And the question has 3. Here we have 6. There is 1. There is 2. We can deduce. We are supposed to divide this whole equation with 2. There is no y cube, but there is y here. So we can multiply both the sides with y square. Now we can multiply both sides with y square and dividing both sides with 2. We will get 3y square dy upon dx into d square y upon dx square plus y cube d cube y upon dx cube is equal to half of y square f triple dash of x, which is exactly equal to what? D by dx of y cube d square y upon dx is square, should be equal to d by dx of y square into d square y upon dx is square. This would be our answer. Let us see the last type of example for this particular method. An equation is given and we have to prove this. We know that we are supposed to find d square y upon dx is square. So first let's write the equation which is given. Ax square plus 2hxy plus by square is equal to 1 constant. Let's differentiate it with respect to x. We will get 2ax plus 2hy plus 2hx dy upon dx plus 2by into dy upon dx will be equal to 0 because 1 is constant. See here, the 2 is common. We can divide both the side with 2 and it would become 1 for the left hand side. And let us rearrange the terms so we can find the value of dy by dx. Let us take dy by dx common for the left hand side and let's take this term to right hand side. We will get dy upon dx is equal to minus ax plus hy upon hx plus by. Say this is result number 1. We are supposed to find the value of d square y upon dx is square. So we will differentiate 1 with respect to x. We will get d square y upon dx square. It would be equal to, let us take minus common, hx plus by and multiplied by differentiating the numerator. We will get a plus h dy upon dx minus ax plus hy into differentiating the denominator. We will get h plus b dy by dx upon hx plus by whole square. Now we do have this value from 1. We can put the value of dy by dx. Plus we can take this minus inside. This term will become plus. So we will write this first and minus this second. So let us do both of these things together. D square y upon dx square would be equal to ax plus hy multiplied by h minus b into ax plus hy upon hx plus by minus hx plus by multiplied by a minus h into ax plus hy upon hx plus by upon hx plus by square. Here we have written minus because this term is minus. Same is case is here. We can take this as LCM for this bracket. Same way we can take this as LCM for this particular bracket. Both the denominators are same. So if we will take the LCM for this bracket, and if we will take the LCM for this bracket, the whole term will be having the same denominator, which will multiply to this thing. So let us rewrite that whole equation like that. D square y upon dx square would be equal to ax plus hy into whole thing will have the same denominator, h into hx plus by minus b into ax plus hy upon hx plus by minus hx plus by a into hx plus by minus h into ax plus hy, and in the denominator hx plus by, and the whole thing also have hx plus by as by square as denominator. This denominator will multiply to this denominator and it will become hx plus by whole cube. So now we just have to simplify this much of numerator, right? Because this denominator, the both will multiply with this, will become hx plus by's whole cube. Now simplifying numerator, it would become ax plus hy multiplied to h square x plus bhy minus abx minus bhy minus hx plus by multiplied to ahx plus aby minus ahx minus h square y. This both term will get cancelled. These terms will get cancelled. We will get ax plus hy multiplied to h square x minus abx minus hx plus by multiplied to aby minus h square y. Now let us further simplify this. We can see here x is common and here y is common. Let us take them common. Ax plus hy into h square minus ab into x minus, let us take minus out from here because it will become like this. So it would become plus hx plus by multiplied to h square minus ab into y. So these both terms are same. We can take them out as commons. H square minus AB into x into ax plus hy plus y into hx plus by. Simplifying this further, h square minus ab into ax square plus hxy plus hxy plus by square. So the numerator would become h square minus ab multiplied to ax square plus 2hxy plus by square. We know this is the question. As we can see, the value of this is 1. So we can write as ax square plus 2hxy plus by square is equal to 1. We will get numerator is equal to h square minus ab. This is the value of numerator. So the final answer would be d square y upon dx square is equal to h square minus ab upon, remember we are not to forget this denominator which we have to multiply to this denominator. So it would become hx plus by whole cube.